So T1 summation I is equals to 1 to n xi square. So that means we can clearly see T1 is sufficient for sigma, whereas T2 is not sufficient for sigma. So T2 is not sufficient. So that means, like, if I consider two values like sigma 1 less than sigma 2, the likelihood ratio f of x comma sigma 2 divided by f of x comma sigma 1, so that is nothing but sigma 1 by sigma 2 whole to the power of n into exponent of 1 by 2 sigma 1 square minus 1 by 2 sigma 2 square into T1. So if I consider, like, so since we are having like sigma 1 greater than sigma 2 greater than sigma 1 by sigma 1 square minus 1 by sigma 2 square is greater than 0. So that means this likelihood ratio is strictly increasing function of this T1. So that means this family, so we can clearly see that the family has monotone likelihood ratio. The family has monotone likelihood ratio in T1. So that means if I consider the distribution under H0, so H0 when sigma is equals to 1, this T1, which is like summation I is equals to 1 to n x1 square xi square, this follows chi-square with n degrees of freedom. And by Carlin-Rubin theorem, since monotone likelihood ratio holds in T1, we can say that the UMP test for H0, which is sigma is equals to 1 versus this H1 theta is sigma is greater than 1, this rejects for large values of this T1. So that means to get level alpha, so we need probability of T is greater than C given H0 is nothing but alpha, and C is nothing but chi-square with degrees of freedom n and confidence level alpha. So that means T1 is greater than chi-square n comma alpha. So if we check the options, so S has monotone likelihood ratio T1 and it is rejected when T1 is greater than chi-square n comma alpha. So option A is the correct answer.